Restart. Okay, we are going to get started. Take your seats. Great. Good morning, everybody. Welcome to Bangkok and welcome to IETF DINRG. DINRG works on the decentralization of the internet. And my co-chair here is Lisha Zhang, and I'm Dirk Kutscher. Before we start, just a few housekeeping things. Please be aware of the note well on intellectual property. So we are following the IPR rules of the IETF here in the IRTF. So in short, that means you have to let us know if you are contributing or observing patent-related contributions. And we also run by the privacy and code of conduct. So one thing that is important, so you, when participating, you acknowledge that like written audio, video, and photo records of meetings may be made public. And there's also a code of conduct and anti-harassment procedure, which also applies to us here. So if you have questions about this, please consult these documents. And another important reminder is that, so this is the Internet Research Task Force. We are not doing standards here, we are doing research. So we generally work on longer term research issues that are related to the internet. And when we do things like RFC publications, these are typically informational or experimental RFCs. Also see the primer for on the IETF way of working, RFC 7418. And so we have a mailing list, we have a webpage, and thankfully we also have note takers today. So many thanks to Sadhu and David for taking notes. Please use the IETF note-taking tool. That would be great. So then everybody can see the notes and can chip in things, and then we can easily also convert this into the minutes later. But yeah, thanks very much for volunteering. Okay. So quite often there's the question, right? So how should IETF groups produce or demonstrate their results? And so I mentioned RFCs earlier. So so writing RFCs and inner drafts is not the only way that research groups can work. So that's why we thought at the current stage of the group, it's quite useful to also have a place where we collect things. And so this could also be something like research papers that, you know, DINRG attendees produce, or other like seminal work that we should organize and share. So we have a wiki for that, and we're collecting information there. So if you think there's something that should be added there, please go ahead and do it. And so hopefully over time we can grow this and make this more interesting. Okay, this is the DINRG wiki. And yeah, so you see that we have a list of things there, and we really want to kind of continuously grow this. Okay, so today we have, again, a very interesting agenda. So thanks everybody who proposed work and proposed contributions. So we will, after this, we start with a quick readout of the CONEXT DIN workshop that we held at in UCLA in December. And then Nisha is going to provide a review of our past months since we rechartered. Also to kind of summarize the discussions that we had in the last two meetings on potential ways forward. And then we have three research presentations. So one by Ruije on IPFS, one by Gareth Tyson on Blue Sky, and one by Tianyuan on comparing app implementations over TCP versus NDN. And so we should have a bit of time in the end, also continuing our discussion on directions, new ideas. So that's also possible if people want to bring up something. Okay, so with that, maybe let me just switch over to the CONEXT workshop. Just a moment. Right, so yeah, so for these research groups in general, it's often quite nice to have meetings outside the normal IETF meeting cycle. That could be like interim meetings, and what's especially interesting is often if you can hold meetings at academic conferences, so to like build connections to those groups and tie in more people and so on. So we tried to do this at CONEXT in December last year, and have a full day workshop there. And yeah, so the workshop was kind of aligned to the topics that we are addressing here in DINRG. So also all kinds of contributions on analyzing root causes, measurements, some technical solutions, and so on. And so this is the overview of the program. So we had like two interesting keynotes I'm going to show you in a minute. And then we had like two technical sessions. So one on more like decentralized systems, and then a second one on more specific technologies for decentralization. And then we had a nice panel discussion on next steps in the end. So the first keynote speaker was Cory Doctorow, who has been speaking here in DINRG earlier as well. So he had a keynote was titled "Dis-Enshittify or Die," how computer scientists can halt enshittification to make a new good internet and condemn today's enshitternet to the scrap heap of history. So yeah, so basically in his keynote, which we have a video of if you haven't seen it, so the link is in these slides later. He kind of explained his yeah, the term enshittification that he coined when he gave the first talk here in DINRG. So yeah, so in his view, basically, yeah, it's like a phased process, right, where platforms try to attract users, lock them in, and then degrade the service over time by selling out private data or setting up the advertisement opportunities. And so he talked about a few things like what you can do against it. So so one of the things is to foster portability, so remove the barriers for users to exit those platforms. And the second thing is also bit aligned to what we discussed here before, is to kind of reinstalling the end-to-end principle for future application development. So foster development on applications that are not dependent on centralized platforms. And so that's something we'll come back to later, also in Nisha's presentation. The second keynote was a bit different, was by Michael Karanikolas. Oops. a professor for law and policy. So he was at at UCLA, now moved to Halifax, I think. And so his keynote was entitled The Fediverse Papers. And so he was looking at some constitutional governance and policy questions for like federated social media systems. And so it was also quite interesting. So he gave an overview of like the history of digital speech and content governance, and talked about these challenges in supporting things like moderation in today's internet systems. And so it's quite we felt it's quite important to have this also non-technical perspectives in these discussions. So in this case, legal, but he also touched upon some economics questions, so monetization, for example. And then he gave a few examples. So what governments, current government initiatives are to kind of balance these different interests, like companies, users, society. And so he was advocating an an intentional and structured process towards this. And so that's quite informative if you work in this field, like for example, federated systems and so on, to also really understand the challenges in the legal realm for decentralized platforms in particular. And so for the first technical sessions on decentralized systems, I can't give you like a full summary of all these talks, but I'll just give you the title, and then you can hopefully read the papers. So we had one paper on Blue Sky. So today we have another Blue Sky presentation, but it's a different one. So this was on Blue Sky and the AD protocol. And so by people working in Blue Sky. And so they described a bit, the design goals, how it works. Then we had a talk about a system called Re-P2P Matrix. So a system that uses decentralized relays in a peer-to-peer matrix system. And then we had another talk by Tianyuan on empowering end users in future networking, talking about some research results, systems he had built at UCLA. And in the technical session number 2, so we had a presentation about like multi-blockchain systems, so atomicity and abstractions for that. And so we had a paper presentation by David and colleagues that looked at the communication cost for permissionless distributed consensus at internet scale. And then finally, we talked about some ideas for a decentralized internet namespace. And so in the panel discussion we talked a little bit about what actually good ideas to follow, right? So what should we actually do? And so we had Corey, Michael, and Dan Massey, who had just been appointed as the NFF director, and also Paul Mocker-Petris, so who I think many of you know, designed the DNS to a large extent. And so the panel discussion touched upon many different things. So, so what I took away from it was with a certain sense of this notion of really enabling or re-enabling a direct user-to-user communication, so without reliance on third parties. And then we talked about what does it take, so what functionality do we need to support that. So, so how to provide identities that are really owned by users, that allow users to establish direct, secure communication channels, and yeah, how to use that for mutual authentication and yeah, secure communication. And so overall, it was a really nice day, really good workshop, good discussions. And yeah, if you're interested, yeah, please read my longer report, which also has links to the videos. And there's also an article on the IETF blog about the workshop. So that was yeah, quite fruitful, and I think we should probably do this more often, right? To like have a so number one, more time for discussing things more deeply, and then also have the ability to invite people who are typically not coming to the IETF. Okay, so that was my quick readout from this workshop. Now I will hand it over to Lisha, who talks about our recent progress.
Okay, let me actually find out where we are. Okay, here it is. So we've been rechartered since July 2023. It seems that not long ago, but it's been a while. Are you going to drive? How do I drive it? Okay. So this is our new charter. We have seen this since the rechartering. Therefore, I put it here just for convenience. People know what we are committed to, but I'm not going to repeat what's already been said many times at this meeting. Let's go on to the next step. So since then, it's amazing that we have already organized so many activities. The workshop that Dirk just summarized, I think that's really very important step. Before we had a 2021 DINRG workshop. That's just our own workshop. I think if we engage in the broader community in academia research, I think it's very important because this is a research group. So we're probably going to look into organizing similar workshops in future conferences, maybe next co-next. That's actually going to happen in, I think, in December this year. So for the meetings we have organized, we have been meeting at every IETF. Thanks to everyone's help and the participation, we really had great meetings. I collected all the meeting agendas here, but it's too dense for you to see. I summarize in 4 major areas. I don't know if I can drive myself. So
Can you?
I don't know how. Yeah. Essentially, I think it's looking back, we didn't really start with saying that we're gonna actually collecting presentations, results of these 4 areas. But looking back, we happened to do just the right thing. The very first thing is to open up our eyes broadly, not only look at the technical issues, but also the legal issues, the case studies, and the separate regulation things. So we had talks not just by the doctoral, but also I think by the 2 law professors. One is from MIT, I remember, talk about the ecosystem evolution and digital infrastructure policies. Then the cyberspace regulation case study by Professor Xing Li at the previous IETF. And then we collected a number of measurement results, measuring from different perspectives. I think even before the recharter, we had some very nice measurement studies. These are the talks since the recharter. You can see that there's a measurement on the existing infrastructure. There's this measurement on IPFS to see how truly or not so being a peer-to-peer file system as the design claimed to be. And we'll look at the DDoS mitigation to say that can we perform DDoS mitigation in a decentralized measure. I remember I had a discussion with the presenter afterwards. That was the last IETF, talking about did their proposed this collaborative decentralized approach actually worked out. I think the answer was not positive. So that's a fundamental reason why the developed solutions didn't seem to get picked up. What's missing? So being a research group, we ask for those kind of root cause questions. For this meeting, right after me, there will be 3 presentations. Let's look at the decentralization from another different perspective. So this is about, so the last one, we talk about the measured behavior of decentralized effort. And here we talk about specific approaches, exactly what you could design to motivate the direction of decentralization. People probably remembered Christian's talk about the minimal global broadcast. He brought in some kind of radio equipment and showing that how 2 devices can literally talk to each other directly and cover some distance as well at a very rudimentary layer 2 protocol without any centralized control over it. We hear about the local first software, and then there's one talk, I forgot to put down the name, by someone actually from the Solid community, where he actually proposed to say that today the big guys, the so-called hyperscalers, collect our data and make money out of advertisement. He made a very strong and specific case to say this kind of revenue does not necessarily has to be collected by the hyperscalers. He made a case showing that even the local mom and pop store can do this very effectively and promote this direction of decentralized applications. I think for people who are interested in that, that's really deserve another listening to the recording of that talk. It's really unique. Then there's this Indian workspace that Tianyuan can mention again. We heard the talk from Solid to show that Solid approach is yet a different one. Their notion is to say, if we provide you completely decentralized storage service, would that be a very effective step toward decentralizing the global internet? So I think that's it's an excellent question, and I think the answer it still need to be fully understood. Then we have the meetings to look into the naming space. We heard about a talk about the DID design by someone, I think from also from the Solid, oh no, the W3C, exploring this decentralized identifier design. Then there's someone from the dance group talked about their notion of providing the client DNS authenticated names so that you can have 2-way certification for the TLS secure connectivity. And then, of course, we're looked into about utilizing DNS names in a more general application as end user identifications. So if you move down to the next slide, so here's the thing. I think the DINRG has been doing great work. We had great meetings, great discussions. Very often the times it's very controversial. I think that's a great thing. The issue I think we need to improve is how we can carry on the work between the meetings. There's very little conversation going on our mailing list. So again, following the question to say, we always ask the why we don't have active discussions between the meetings. So there's 2 speculated causes. I put the third one to say maybe there are other reasons, and we hope you can help us identify. I think the presentations, as I mentioned before, are the great input into the DINRG effort. They're normally done by the researchers outside the IETF or IRTF. And therefore, therefore, we are not really following up with what they may be doing next to actually keep track of things and making new progress on that. And the second thing is that for our own conversations, discussions, although we very often see different opinions, those things are talked at a very high level, and therefore there's no concrete effect to prove or disapprove which is specific opinion, whether it's correct or incorrect. So I don't know if other people can have other speculations of why we don't have active email exchanges. For example, I guess one reason could be everyone's super busy. That's probably very true. But given that we created this research group, that means that people do have the interest and hopefully also the obligation to move this work forward. So Dirk and I discussed how we move this group forward in a more productive way. This actually started from the last meeting. Remember, I said we didn't have much of the email conversation, generally speaking, over the years. But before the last meeting, we did have a very intensive period with the email discussions. And we made a nice summary. If people don't remember details, look back the minutes from the last meeting and the presentation slides. This is captured as a result, the summary of that email exchange. This is from the last meeting. I literally copied here. We copied the Christian Huidema saying that to really get concrete work done, we probably need to commoditize a number of platform components, naming, discovery, introduction, I would call it bootstrapping, security. So how you do that? You cannot just talk, you have to do it. So therefore, focusing on a few specific applications seem to be one concrete step to move forward. Then developing the platforms to enable those applications. So Christian Huidema ended up by saying that, so maybe identify a couple of applications first, then move forward with that. That's what we are doing for this meeting. If you go to the next slide. So besides Dirk and my talk here, we solicited 3 very different application cases. Each of them aim at decentralization. The very first one is IPFS, and this time let's take another measurement look to see exactly how IPFS actually works and who's using it and who's providing the service, for example, providing the servers to do this so-called peer-to-peer file sharing. I think it's a very interesting piece of work, and that will really provide concrete material to answer the question, can blockchain-based designs lead the internet to decentralization? The second paper is about blue sky. It's a very interesting paper as well, understanding to what degrees blue sky succeeded or not so successful in decentralization direction. And the third one is really about how you can design an application that is truly, truly decentralized by comparing the implementation of a decentralized app over different protocol stacks. So again, this is the slides we actually showed the last time to say we have 3 things to do measurement that improves our understanding and will overcome centralization. What details we added this time is that you can see that the measurement shouldn't stop or stay at the network level, just watch the traffic. What gets centralized? I think in some earlier conversation, from the 2021 DINRG meeting, DINRG workshop, we already pointed out the centralization started from centralizing the application services. So therefore, the measurement to assess how much internet gets centralized needed to focus at the application level, in addition to what you measure at the network level, or maybe should have more focus on the application level. And improve our understanding is that we really look at the specific decentralized apps and to understand whether they succeeded, and if not, why not? Then to really overcome the centralization, then we need to look for effective means to get there. From the Dirk's talk, you heard that near the end of that workshop panel discussion, they actually made the recommendations to effective means for decentralization. So they basically pointed out that we have to enable direct user-to-user communications. Today, that's not doable. There's so many laptops in this room. Can any laptop talk to any other laptop directly? You cannot. And why you cannot? And that's a great question to find answers for. So in that workshop panel, it basically concluded that if you really want direct user-to-user communication, you need to solve two very difficult problems. One, to communicate, two parties need to be able to recognize each other. Internet started by any host talk to any other host, but that was back in the 80s. Every host is represented by IP address. Today, not only you and I don't have our own IP address that's representing me, but rather you cannot do secure communications. Back in the 80s, we didn't have security on the communication. That was okay at that time, not now, 40 years down the road. So therefore, to enable direct user-to-user communication has two requirements. One, how would the user get identity? Two, how you secure this communication? I think those are the things that DINRG should really look into. So what's the best realistic roles that the DINRG can play? So definitely, this is really a great platform, for people to come here, report what they have discovered and the related topics on decentralization, like what we have been doing. But more so, I think we need to pick up specific, challenging research topics and work closely with maybe related IETF working groups on the user identity and the user communication security challenges. So that's the end of my summary. We made this summary because we are due to a review by IAB. So we thought we would do this review, sharing with the group first, and solicit feedback, if any, then we'll report to the IAB this week. Thank you.
Yeah, we do have time for questions or comments.
First session of the morning, you always have to figure out how to make the microphones work.
Yeah, okay, thanks for turning it on.
Setting it on helps. Yeah. Colin Perkins. I mostly just wanted to thank the chairs, thank the participants in the group. I think the group has made some really excellent progress over the past couple of years since rechartering. And there's been some really fantastic talks, some fantastic discussions, and I encourage you to keep going. There's really nice work here.
Yeah, thanks very much. Yeah, please.
Hi, Andrew Campling. I suppose addressing the question that you sort of posed about how to generate more activity, to sort of simplify the part of the question. I do wonder, I think it's obviously a great thing to go to academic conferences. I would suggest also consider going to some more civil society orientated conferences and be clear what for lack of a better phrase, the harm that centralization causes is, because that might suggest which would be the right sorts of civil society conferences to go to. And also, for example, the IGF would be an obvious place to go as well. I think DINRG could make a useful contribution at the IGF middle of this year. So I think there's some places that are not academia where it would generate useful engagement to try and talk through with some of the people on the wrong end of centralization to get their energy and involvement. So it's not just seen as an academic problem, dare I say, in a research group. Just a thought.
Yeah, thanks. These are great suggestions. So IGF is on our radar, so that's something we may actually be doing. Thanks.
Aram Welling from Oxford Information Labs. So I extensively attend ITUT, by the way. It's my first IETF meeting. And I certainly see a lot of proposals in ITUT related to some very similar concepts. So with every new concept, there are pros and cons. I have not heard one con yet, and that makes me a little wary. I come from a computer science background, and the cons that I heard were something related to making money and some kind of centralized control. I'm not sure. But I am eager to hear just a little bit about the cons. Nothing's ever perfect in this world, okay? And in order to get buy-in, I would like to understand a little bit about what are the cons that have been discovered thus far.
So you are talking about cons
Yes,
for
peer-to-peer.
Yeah.
I'm talking about peer-to-peer communication with identities, decentralized. I'd like to understand that further. Thank you.
Well, let other people answer that question, then I have my answer.
Hi, sorry, Vittorio Bertola. Well, first of all, I also think that you should try to go through the IGF, but as someone has just presented the proposal, the deadline was yesterday. So I think, but still, maybe you, if any of you wants to come to Norway this year, we could try at least to see in the program with others sessions. I mean, I was one of the panelists in a workshop exactly on like this topic together with Cory Doctorow and people from the European Parliament 3 years ago, the Polish IGF. I must say that the IGF is a nice place, but there's no decisions ever coming out of it. But still, it's a good place for networking. On the other hand, my note on this is that I don't think maybe it's right this way. I mean, we don't need to deal with it at the IETF. But this idea of we have to decentralize peer-to-peer, etc., which is commendable, and it's fine that we pursue it. Maybe it could have worked 10 years ago. I mean, now all the governments of the globe are working for their own sovereign internet, regulated internet, trying to break out the limit part of the internet and impose the rules and that to counter the centralization that has been there for like 10, 15 years. So this dimension of the pressure for national digital sovereignty or whatever is sort of absent from this discussion here. I don't know how we could fit in, honestly, because it's against the original idea of the borderless internet, but it's the reality today in many parts of the world. Certainly it is in Europe. So I have no proposal, but I wanted to flag the issue.
Right. So, yeah, so we have to be a little bit careful here because there are topics that may just be out of scope for DINRG. So all the questions that relate to like the larger governance of the internet is quite sensitive. We probably don't have the expertise here to discuss it at length. I just wanted to respond to your questions with the cons. So, okay, maybe we haven't summarized this really well, but so what we have done, and I also want to continue today, is to have a critical look at some of the proposed systems and technologies. And because you are pretty well aware that many things are proposed to encounter centralization. And so I think that's one of the contributions of this group, that we have kind of looked under the hood and then, have seen how decentralized are they in reality, how they are actually used, and also to what end can you actually replace current systems with these proposed approaches. And So that's something we have been done and we also continue doing.
Well, if we answer your question, what's the concept of peer-to-peer? The question is, I think it's not the right question because today you cannot do peer-to-peer. Like I said, your machine cannot talk to my machine for two reasons. One, there's no such a notion that end users should have identifiers. And that we want to push that direction. That's what we put down to the end. You can see that we want to work with the related IETF efforts to push down the direction. Can users have identifiers? And if so, how to achieve it? Okay. For peer-to-peer, you have to have identifiers so you can communicate it directly. And to communicate directly, you need to use the user securities.
Would you like to speak first?
No, but it doesn't matter. You can go ahead.
Okay. George Michelson, APNIC. I wanted to speak in support of what Erin was saying. I may have misunderstood, but I felt that she was saying a sound scientific approach to research in this space should have a neutral position and should review pluses and minuses of all classes of technology. And there is a huge burden of assumptive language in this presentation that enters the room with an assumptive statement, we must do something to defeat centralization. I felt her comments were saying, we have not presented adequate evidence as a research group to determine a position forward because there is no rational statement of pro and con components of argument. That was how I understood your argument. The second thing I wanted to say is that I think, Lisha, you have spoken extremely strongly to a statement that says cannot. And I would feel as an observation, it is appropriate to say do not, because we do not see end-to-end peer-to-peer conversations without the operation of a mediating third party. And it would be appropriate to say without a consistent naming model and a mapping of naming to addressing in some fabric, it is hard to see how it could work. But I am uncomfortable with the strength of your language that says cannot. I feel that is, please forgive me, but I feel that is somewhat assumptive of a position you hold that is not, if you like, held in the wide. I don't think cannot is given yet. Do not, I am comfortable.
I agree with that. Thank you very much for pointing that out.
Thank you. I think we had a complete mind melt because I don't need to say any more. I think he captured it all. Thank you.
Rahul Gupta. Before I even address this, just to the room, please add yourselves to the queue because it makes things even with the remote participants.
Also, the note takers will be much helpful. Thank you.
Okay. And I have a short and sweet comment. More regulators, more economists, please.
Yeah, thank you.
Jim Reid, no affiliation other than my own consulting company. I think some of the comments have been made are very valid. I think about the remarks that George Michelson made a few minutes ago. One thing I would like to suggest that this working group or this research group should consider is trying to do a little bit more engagement with external organizations that are dabbling in all sorts of technologies related to this. I'm thinking, for example, some of these IGF type things and perhaps ITU, perhaps IEEE. At the very least, they should have visibility in these places of what this research group is doing, and if they've got interesting stuff to come and bring it here if need be. I think that would be very helpful because I get the perception from spending far too much time in ITU that there's no visibility of what the IETF in general is doing and this particular research group in particular. And that's potentially harmful because there's all sorts of crazy stuff going on all over the place. And I think it would also help if those kind of ideas were then getting challenged and also we're getting evidence backed. responses to that stuff. So I really want to emphasize what George was saying before, doing stuff that's evidence-based. We all agree that centralization is a bad thing, but have we got actually any data or any proof of that in terms of how it's affecting the network? We know it's a bad thing, but where's the proof?
Right, thanks very much. Yeah.
Hi, Dmitry Kuznetsov. I'm from the University of Amsterdam, so academic affiliation. First, I wanted to echo some of the other comments that talked about engagement with other organizations. I wouldn't say IGF proper, but rather regional IGFs would be a good approach, because you will actually be able to talk with a broader range of stakeholders and people from different regions. Because one of the big issues is that I think there are cultural and social differences that result in different understandings of what peer-to-peer implies and what this type of naming implies. Another comment is related to perhaps improving understanding and specific case studies. I am intrigued by the idea of using the DNS as a platform for creating unique identifiers, but I'm wondering if people have already considered the feasibility of doing that in ICANN's policy development process, considering the experiences of the first round and the debates surrounding community applicants or closed generics or internationalized domain names. With that, these are my two comments and a bit of a question. Thank you.
Okay.
Just for your last question about whether ICANN has considered this. It happened. I talked to someone related to ICANN about this idea at this IETF. So there's a proposal that maybe we'll give a talk at the next ICANN meeting. Thank you for that comments.
Morning, I'm Dirk Trossen, Huawei, mainly speaking in personal capacity. I want to echo what was said before about the assumptive language. I think point 1 and 2 on your list there, I very much agree with. Point 3 outlines a need for something that I don't think is well understood yet, and we have to be very, very careful. I think one of the things that may be very good to start with 1 and 2 is trying to understand the interplay between centralization and decentralization. I think David put on the list work that we've done on understanding centralization in an otherwise decentralized design. It's just very interesting to understand why there is sometimes, even in decentralized design, a need or at least a desire by the community to still centralize. That's an observation that simply happens. I think understanding that is very, very good to understand what people really want to do. And it goes again into the peer-to-peer discussion we had before. Not doing things may not have anything to do with not being able to do it. There are certain aspects that drive users to use a certain either trusted player in between that leads then to centralization, whatever it is. And I think understanding those and quantifying those and describing those aspects that drive certain solutions to decentralization or to centralization is a good starting point. And then we can try to see how much of number 3 on your list up there, overcome centralization, is really still required. So I just want to put that out. But 1 and 2 is definitely something we should drive forward with much more work. Thank you.
Personal opinion. 1, I agree with you. Yeah, that's why I think the first 2 is really important. Measurement and understanding. I think there's also another point we haven't really spoke out very clearly. What is the definition of decentralization? Is blockchain representing the solution space for decentralization as an example? I just want to say that we need a clear definition of decentralization.
Yeah, if I could quickly come back to this. I think David's email that you sent on the discussion we started having, it may have responded to the wrong draft on, I think the draft was related to CDN, but I was exactly trying to do that, trying to see what is the right definition and what are the spaces in which centralization actually happens. Centralization is not only an aspect of technical discussion, it's also a discussion on adoption, on economics, on policy, and it's really important to separate those. in order to structure the discussion a little bit.
Right. I mean, thanks. But just to be clear, I mean, we had quite many discussions on these different aspects. So like infrastructure centralization, control power centralization. So it's good to, you know, distinguish these things, of course. But you know, one of the observations, if I can say, is that well, clearly the the technical centralization of infrastructure that had to do with also providing, you know, secure communication in the first place, yeah, just has been exploited to a large extent by you know, players in that field to extract data, monopolize data, and so on. So these kind of connections or these yeah, interplay between like the technical and then the economic and control power centralization. This has been discussed a lot by people like Jeff Houston, for example, in his talks. I agree that we should keep doing that and maybe find a more structured way to kind of record the results and you know, produce, kind of guide the kind of more productive solution-oriented work in this group. So I think that I fully agree.
Hi, and Andrew Campling again, just actually building on your point, a question for the chairs. From a quick look on the sort of research group sort site, that there's not a document that actually has definitions written in it. And I wonder whether it'd be useful to actually have that written down and adopted as a document by the research group. And similarly, if sort of building on the discussion just now on if we accept that there are some clear sort of problems caused by centralization, again, writing those down so there's a if you like, some structure to the discussion would be useful in my view. I don't know if you agree if that would be worth doing, but I think it might be helpful just to have something adopted by the research group, so we have a sort of a common starting point.
Right. So admittedly, yeah, we have been thinking about this and had a bit of a hard time to find, you know, what's the best way to write up these things, you know, how to establish consensus on terms. Yeah, for that, I think we really need more engagement also, and you know, suggestions on the list, on the contributions, basically. So this cannot be, you know, just solicited by the chairs. I mean, we can solicit, but then if we need input for that. Thank you.
I just add to that, Rahul mentioned that getting more economists and policymakers. Please help us engage those community.
So we have to move on. Colin, if you want to say something while we bring up the slides.
I won't take the time if you have to move on. I was just going to say it's clearly important to write things down. Given a topic like this, I would question whether the right thing to do is to write things down in the form of RFCs, or the right thing to do is to have a debate which leads to a bunch of papers, which you can then, you know, have a pointer set of papers that talk about this, because what people should be coming at this from a range of different angles, not just from the technical, from the economic, from the political, and so on. And I think there's going to be a range of different definitions and views on this.
Great, thanks. So we had one publication actually in ACM CCR that reported on our earlier workshop, and it might be a good idea to do something like this again. So also if people want to contribute and help with that, we've been very open to do that. Okay, thanks everybody. Again, very good discussion, many good points. So we'll definitely consider those. And yeah, I hope we can you know, move this group forward in a really productive, useful way. And it's really good to kind of see what everybody's thinking. And so we have to find a way to keep that momentum also in between our meetings. So that's something we have to work on. Okay, now it's our pleasure to welcome Richard Chief from George Mason University, who is going to talk about a recent paper that he and his colleague published on a closer look into IPFS, accessibility, content, and performance. And I'll give you control of the slides, just a moment.
Okay, thanks.
Should work now.
Let me try. Okay, it works. So can you hear me?
Yes, it's a bit, you can hear very well, but quite loud. If you can keep some
Oh.
distance.
Lower your volume.
It is good?
Lower your volume. It's
Okay.
too loud.
What about this?
Control here.
Yeah, I could.
Maybe you can just talk in a quieter voice.
What about this?
I think we can live with that. Yeah. Let's try this.
Please get started.
Okay. I hope this doesn't cause trouble to you. Okay. I'm sorry about that. So, hi everyone. My name is Ruizhe Shi, a third-year PhD student from George Mason University. And the first thing I want to say is thank you for offering this opportunity. It's my great honor to present my work in this conference. So let's get started. So today I'm gonna present our work about IPFS, the interplanetary file system. In today's web ecosystem, we're using the client-server model, which is a centralized model. This model has brought about many benefits, like better user experiences, but however, it also creates concerns like user data privacy, because most services are provided by some third large tech companies. While IPFS aims to change the status quo, essentially, IPFS is a distributed storage system that is built on top of a peer-to-peer network. The biggest goal of IPFS is decentralization. It also has benefits like deduplication, data integrity, and faster transfer. And currently, IPFS is the largest peer-to-peer network. It has attracted millions of users. And next, let's talk about some background about IPFS. The core concept behind IPFS is the content addressing, and that is every file or content has its own content identifier, the CID, which is calculated by a hash function. Upon uploading a file into IPFS, the file is divided into multiple chunks. Each chunk has its own CID. And after the file is divided, the IPFS will create the parent chunk of those subchunks. And those parent chunks will store the link information indicating how the subchunks are organized. And finally, we will get a tree structure of the original file. In contrast, when we download the file, And the downloading approach follows a top-down approach. That means we start from the root block, from the first layer of this tree. And this figure is an overview of the IPFS network. The most important component is the DHT, which stores the CID and provider address mapping. When it comes to the IPFS content retrieval, there are basically two ways. And number one is by accessing an URL of the content through the IPFS gateway. And number two is by installing an IPFS client. And this way has two stages. The first stage is lookup. It's either done by asking the neighbors or querying the DHT. And the second stage is the actual data transfer or downloading. This is done by the bit swap protocol. The bit swap is the default block exchange protocol in IPFS, and I will discuss this later. And next, I will talk about my work from 4 dimensions: accessibility, content types, and content providers, and performance. For the datasets and the methodologies, we have used 2 datasets. It has 2 types: the bit swap logs and the gateway logs. The bit swap logs essentially is the bit swap messages passing through the IPFS peers, while the gateway logs is the browsing history from the gateway side. Through our experiments, we try to access over 10 million CIDs in over a 2-week period. And first, let's talk about the accessibility. And this figure shows the downloading progress of the Gateway 22 dataset. Gateway 22 dataset is a gateway dataset obtained from 2022. And this dataset is 1 year old since our experiments. As we can see in this figure, in day 1, we accessed all the CIDs in this dataset, but only half of them can be successfully retrieved. And in the next day, we try to access the unavailable CIDs, but there is still a small portion that is unavailable. And we'll repeat this process in the next 4 days. We employed this methodology in all the 4 datasets. As we can see in these 4 figures, no matter how young the dataset is, even the 0-day-old datasets, there is still some CIDs that are not instantly available. While some people may argue that IPFS is not designed to guarantee permanent file persistence, which is true, but however, we argue that for some kind of files, for example, the NFT files and the video streaming files, availability is very important. For example, on day 1 in this figure, some NFT files and video streaming files are not instantly available. This will potentially block the NFT transactions. So although IPFS is not designed to guarantee the file persistence, it is still necessary to provide such functionality. Next, let's talk about the content types. In this section, we categorize the content types into 5 categories: the image files, the unknown files, which are the unknown file chunks, and the video streaming files, and the normal files, which is for ordinary usage, and the NFT files. And this table shows the content types in our Gateway 22 dataset. As we can see in this table, over 70% of the files are either JSON files or image files. Another observation is that over 80% of the storage is covered by either video files or image files. So that essentially means that IPFS is mainly used for the NFT services and the video services. And next is about the content, the types in detail. So we further categorize the files into NFT and media and normal files. And we can see in this figure that currently IPFS is mainly used for the NFT services. And next is about the content providers. In this table, the storage nodes and the cloud nodes are those nodes located in the centralized cloud centers. In contrast, the NAT nodes is considered as the ordinary users. As we can see in this table, the number of the ordinary nodes and the centralized servers is very close. However, over 95% of the files are provided by the centralized servers. So this essentially means that in reality, accessing IPFS is actually accessing a small number of centralized servers that is located in the cloud centers. The reason behind this, in my point of view, is more related to how IPFS is used. In the previous section, I have shown that the IPFS is mainly used for the NFT services. When storing the NFT services, users are more likely to rely on some third-party services for storage. So another aspect is the infrastructure limitations. So currently, the net services prevents the ordinary users to join the network because the ordinary users cannot join the DHT network if they don't have a public IP address. So the next is about the performance. The retrieval performance can be further divided into the lookup time performance and the downloading performance. For the lookup time performance, in this figure, we can show that intuitively, the smallest size group is supposed to have the best content retrieval performance. But however, in this figure, we can see that the second smallest size group has the best retrieval performance. This is very counterintuitive. The reason comes down to lookup time performance. As we can see in this figure, the blue curve, which is the smallest size group, has the largest lookup time overhead. In contrast, the smallest size group and the second smallest size group has a similar downloading performance. This is counterintuitive, as the file size is supposed to have nothing to do with lookup time. So we further look into the content providers of those smallest size group. In the second figure, we show that the smallest size group has a higher percentage of net providers, and those net providers has worse lookup time performance. And the content stored in the smallest size group are mostly the unknown chunks, which are not cached in the DHT. And the next is about the downloading performance, the throughput analysis. In this figure, we show that for the large files, the throughput decreases with the file size. Well, for the median value, the small files is even 1,000 larger than the largest size group. And the reason comes down to the file retrieval mechanism in IPFS. Currently, IPFS is using the bitswap protocol to transfer the blocks. It uses a top-down approach, as I mentioned. So it starts from the very top, the root block. The root block needs 2 RTT to be fetched. So this process is like the client sends a 1/2 message to the provider, and then the provider responds with a half message. And next, the client further sends out a 1 block message. And finally, the provider responds the actual block, which takes 2 RTT. For the subsequent blocks, the process is easier as we have known where is the provider. So the subsequent blocks only needs 1 RTT. The client sends one block message, and then the provider sends back the actual block. So where is the problem? We can see that the downloading mechanism in IPFS is very passive. Only when you ask for the block, the provider sends you back the block. While in some protocols like HTTP and FTP, the downloading is actually a stream. This is a more proactive downloading approach. And on the other hand, the Merkle tree file structure needs to resolve the file structure, and then we can fetch the actual data. So this essentially means that we need extra overhead to traverse the Merkle tree. This becomes very severe when the file is a directory, contains very, very deep file structure. So an intuitive solution to this is by modifying the chunk size. As we have shown in the experiment, the larger chunk size can significantly improve the downloading throughput. And here is a summary of our results. We have analyzed IPFS from 4 aspects: accessibility and type, content types and content providers, and performance. So here is our major takeaway. So IPFS currently is far from true decentralization. We analyze this from 2 aspects. The first is the internal traffic. As we can see, most of the content are hosted by less than 5% nodes, and most of them are cloud providers. And in a recent paper, have shown that the nodes that are concentrated in the US and Europe. And there also exists some accessibility disparities. That the content stored in the cloud centers has better availability, while the content stored in those non-cloud nodes has worse availability. So here comes the question: how far can IPFS become the next generation web? In my point of view, there are 2 important issues to be considered. The first one is the performance. Many works have shown that IPFS is not comparable to traditional protocols like HTTP in terms of performance. So in this case, the users are not willing to use it. And the second issue about performance is that when you try to join the IPFS network, you need to make your IPFS node active consistently. This will consume a lot of energy and resources of your computer. And this is not ideal for some mobile users. And the second important issue is the churn. In my point of view, the churn is more related to the usabilities and performance of IPFS. If those 2 issues can be solved, and maybe the churn issue can be solved. But we have some short-term fixes. For example, we can try to publish some cryptocurrencies to encourage users to join the IPFS network. And there are also other issues need to be considered. For example, the privacy and security. Well, in my point of view, the performance is the most important and the most obvious issue to be solved. Next, I want to talk about some performance design trade-offs in IPFS. So before my talk, some audiences have discussed the cons of decentralization. One of the cons, I think, is the performance. As we have known, IPFS has incorporated many decentralized components, for example, the DHT and the Merkle tree structure. Those structures prioritize decentralization, but they sacrifice performance. A potential solution, which is the current solution of IPFS to mitigate this, is by incorporating centralized components, for example, the indexes, the hydro boosters, and the gateways. And this has proved to be efficient, but as a consequence, decentralization is compromised. So for the future pathway, I think the best strategy is to modify the protocol. For example, how can we modify the DHT algorithm and hierarchy to speed up the lookup time? And how can we modify the bit swap protocol to speed up the data transfer speed? So IPFS is still in its early stage. As the largest peer-to-peer network, it still has a long way to go. And currently is still far away from true decentralization. But as a researcher in IPFS, but I believe it's very promising. And that's all for my presentation. And thank you for listening. And I'm sorry about the slides is very lagging. And this might extend my presentation. I'm sorry about that.
No worries. Yeah, thanks very much, Roger. Thanks for an interesting talk. Let's see whether there are some questions.
Hi, Colin Perkins. I think what is this working?
Yep.
Yeah. I think what is interesting is that we see the same economic arguments coming up every time. The one of the conclusions here seems to be that the centralized infrastructure is an important part of IPFS because it has high capacity, it's robust, it's reliable, it's available, and so on. And some of the earlier papers looking at Mastodon and the Fediverse, for example, came to very similar conclusions and had very similar measurements. And obviously, there's a strong benefit to spending billions of dollars building high-performance infrastructure. I guess the question is, what's the economic model for building decentralized infrastructure?
This is a very good question. So the economic model, so your question is how to build a more economic centralized infrastructures, right?
Yes.
Oh, okay, thank you. So currently, to my knowledge, the incorporation of those centralized components is actually very economic. So because those hydro boosters are very cost effective. You can only, like, for example, incorporate like 10 pairs of those hydro boosters join the network, and the performance can be improved very significantly. You don't need to deploy millions of peers, millions of those centralized peers. You only need a very small number of them. You don't need a lot of them.
Yeah, and
that is my knowledge.
And I think that's sort of getting at the sort of point I'm trying to make is that a small amount of centralized infrastructure can make a massive difference to the performance of these decentralized networks, which is a clear pull towards centralization. So if the goal is to decentralize, then what's the model such that is no longer the easy way of improving performance?
Yeah, that's a very good question. So in my point of view, incorporating centralized components is just a very short-term fix. In the long run, we need to modify the original protocol. Okay, you can go ahead.
Hi, Baba Bajpayee, House of Platinum Institute in Germany. So IPFS borrows many ideas from BitTorrent, right? And so this protocol that existed in the 90s. And the bigger problem with BitTorrent was not how it was decentralized, but how it was becoming a platform for hosting and delivering illegal content. And I have a feeling IPFS is going to go in the same direction at the end of the day. And so what concerns this working group, specifically DINRG, is can IPFS become an alternative platform for storing content which is legal and copyrighted? Have you looked into how much of the content is actually that is stored in IPFS illegal content? Who owns the ownership for this content? How can IPFS make sure that the content that the peers are owning is copyrighted and then they have the right to this content? I would imagine performance is an issue, but not the primary issue here. It's the ownership of content.
Yeah, that's a very good question. So in our paper, we have categorized the content into many categories, including the illegal content. For example, the copyright, for example, the content that has copyright issues. So, and we, in our research, we have shown that in the streaming services, nearly 40% of them are related to X-rated contents. As for the solution, current IPFS is using a block list. The block list contains the CIDs that are harmful. So when a user tries to access those harmful CIDs, and the messages will be blocked. That's the current solution. Thank you.
Oh, it's me. Okay, I'll be quick. We are out of time. I have two questions. One is that given that most of the storage actually is in the cloud, isn't that a violation of our original design goal where IPFS is stated as peer-to-peer file storage? It's no longer peer-to-peer per se. I'm not saying that peer-to-peer is a must, but I'm just saying that the end result is not what the design goal started with.
Yeah, that's true. The design goal is peer-to-peer that, so everyone can join. But the reality is the cloud nodes are more reliable. They are always online, and they're more likely to be the powerful guys in the network.
So
in contrast,
is the design goal started wrong in retrospect? My second question, we can get this offline given the short of time. And second question is that looking at the content types that you people discovered, is that really a general purpose of file storage, or it's a special purpose for specific content types? I'll just leave that for the longer term answer. Thank you. Yeah.
Hi, this is Dirk Rossen again. thanks for the insights. They're very much aligned with some of the work we've done on Ethereum, which found very similar cluster behavior in cloud, and it goes to Licia's observation. Then it's just not a peer-to-peer system. But in answer to Colin's question, which may also be aligned with what this research group could care about, and that is protocol design, some of the ideas that lead into how could you discourage the placement of peers in cloud leads you to rethinking the identifier space quite clearly. If you run a protocol over a randomized ID space, and the economic forces essentially, or convenience, whatever it is, leads you to utilizing peers in a cloud system, you can also devise identifier structures that discourage or incorporate structures of, for instance, cloud ISs into the identifier space, and therefore discourage you or penalize those peers that are primarily being based in the cloud in the cloud infrastructures, right? And so there are some suggestions for Ethereum, and I think they equally apply to IPFS, to do that, to incorporate more structural knowledge, underlying infrastructure knowledge into the identifier space, which then leads to peers that are not within cloud infrastructures to be favored. So that's one direction maybe, to look into. And I think as a protocol defining or body like the IETF/IRTF, that may be of interest to the group here. Thank you.
Thank you.
Okay, thanks very much. So we have to move on. Thanks again, Ruja. A very interesting talk, and hope to see you again soon. Just a moment.
We are short of time now, so finish straight.
I was not so interested in the take.
You check out for your slides.
Yeah, I want to share, but I cannot control it right now. Just 1 second. So I lost control about the sharing. That's the problem. Can you click on the sharing button? I can't switch the sharing anymore. This one. Yeah. Just one moment, guys. We're trying to allow you sharing.
If it's useful, I could send you the PPT.
Yeah, it will be the same problem, I think. Just give me a moment. There's something wrong here with my video.
The sharing didn't work.
It was to share.
Oh, it works
okay.
now.
Now it works.
Okay.
No, you are trying to share something. Yeah, but somehow it's okay. Gareth, could we possibly use the PDF that you shared?
We could, but it wouldn't make much sense because the things will overlap and the animations probably won't.
That's a pity. Can you try to share your screen again?
Yeah.
So don't. So. We see the request, but we can't do anything about it. Yeah, even that doesn't work. So I can't share anything. Right. Yeah, so sorry, we can't really get your screen on here. So we have to work with the PDF. I'm sorry.
Okay, well, in which case I should probably apologize to you guys because it'd be a little less understandable. Let me see if I can control this.
Wait. That's okay. Okay, go ahead, please.
Right, yeah, got control now. Okay, great. So thanks, everybody. For those who don't know me, my name's Gareth. I'm a prof at HKUST and also at Queen Mary University of London. And today, Dirk asked me if I could talk about a topic that I've been working on for a few years now, which is the decentralized web, and more specifically, the decentralized web in relation to social media. Before I kick off, I should also give a quick shout out to Leo at TU Darmstadt and Saidu at City University of London, who's actually in the room today. So they were the lead authors who did a lot of the heavy lifting. So if you're curious, please do grab Saidu at the coffee break. So hopefully this will wake you up in the morning. I'm guessing most of you recognize this person. And when you see him, you're immediately getting an emotional reaction. And I guess for many of you, that reaction is not a hugely positive one. I would argue that actually the community owes this person a grat of gratitude because he's brought decentralization back onto the headlines. You might remember in 22, in October, he took over Twitter, and the changes he enacted precipitated quite a large migration of users out of Twitter to alternative platforms like Mastodon. And for this reason, a lot of people started to talk more regularly about decentralization and decentralization of web architectures. Also, he really headlined the risks that come from having one large corporation owning and operating half of the world's social media. So back in the early days when Musk was doing this, Mastodon was the poster child for decentralization. But more recently, many of you may have come across this more new platform called Blue Sky. Just quick show of hands, how many people already know of Blue Sky or maybe even have accounts? Okay, great, quite a few of you. So for those who don't, Blue Sky is a microblogging service which looks very similar to Twitter. You can post messages, you can follow people, and you can interact by, for example, commenting on someone's post or maybe liking it. What is different to Twitter, however, is that Blue Sky aims to operate in a decentralized way so that it doesn't fall into the same centralization traps that Twitter did. And what I'm going to talk about today is where in the spectrum of decentralization Blue Sky falls. So on the one extreme of the spectrum, you've got these central players, the Twitters and the Facebooks of the world. These are operated by one corporation, and if they wanted, they could kick you off the platform or they could delete your posts without any issues whatsoever. On the other end of the spectrum over here, we have the entirely decentralized platforms. So these are platforms like Memo.cash or Nostra, which operate in a highly decentralized way with very few control structures. And it would be extremely difficult for one or even a collection of players to delete your account or delete your posts. Then sitting somewhere in the middle you have platforms like ActivityPub enabled Mastodon or Farcaster, which operate in a somewhat middling position where they have central components, but they also have more decentralized components. And the question I want to tackle today is, well, where does Blue Sky sit in this spectrum of decentralization? So to answer this question, we've got to first deep dive into the architecture to show actually how does Blue Sky work, because it's quite different to platforms like Twitter. I had some beautiful animations that made this incredibly seamless and easy to understand, but I'm afraid in the PDF version, you're going to have information overload straight away. So let's imagine you wanted to create an account. So on the left-hand side here, you have a few of those people. So we have a lovely picture of then Dirk, we've got Thomas, and we've also got Matthias. Now, in Twitter, when they create accounts, essentially a row gets added into a database, and that database is centrally operated by Twitter. In the world of Blue Sky, accounts are not like that though. So in Blue Sky, your account handle is actually a fully qualified domain name. So for instance, you can see that we've got dirk.bsky.social and thomas.bsky.social. Now, the reason that using the bsky.social TLD is because for them, this is much easier, right? So they don't need to manage their own domain to create an account. So Blue Sky offers this functionality because it just makes users' lives easier. But Matthias at the bottom, he's a little bit more hardcore. So Matthias can actually create his own fully qualified domain for his own handle. So here we got matthias.tudresden.de. So this tries to decentralize identity ownership, which is one of the core design requirements that Blue Sky set out to match. Now, the next thing one of these users might want to do is start posting messages. Now, in the world of Twitter, when you post a message, again, what happens is you contact one of their servers and a row gets added into a database. In Blue Sky, however, they wanted to avoid having that one central point of control. So they introduced the concept of a personal data server, or PDS. Now, a PDS is essentially a compute node, which theoretically you can operate yourself. And in that PDS, you can have repositories, and each repository is the data style of your own personal data. Now, to make life easier, Dirk and Thomas might choose to use one of the standard Blue Sky PDS repos. So that's operated and managed on your behalf by Blue Sky. But Matthias, again, he's feeling a little bit more hardcore. So he can actually own his own PDS. So he can set up a server in his office, he can install the Blue Sky software, and he can then run it there locally. Now, once they've got that, in a sense, they're controlling their own data because they're operating the local repo that they own. But the next challenge becomes what happens when, for instance, Matthias wants to talk to Dirk. So maybe he wants to comment on one of his posts or maybe like one of his posts. Now, the most obvious thing that could happen is Matthias's PDS, following this green line, might connect up to Dirk's PDS and send a message. And actually, that is indeed perfectly possible. You could do that if you wanted to. But the problem is this is incredibly inefficient to have all these PDSs talking to each other. So to overcome this, Blue Sky introduces a centralized component. And this is where things start to become a little bit more complicated. So they introduce this central thing in the middle called the relay. And what the relay does is it connects to every single PDS in the world and it consumes their data. So whenever Dirk posts a message, automatically the relay pulls that and copies it across from Dirk's PDS. And this creates a large central heap of all the data. And what then happens is the relay, using an open web API, makes that data available to everybody else in the world. Now, at this point, you might be thinking to yourself, well, that sounds incredibly centralized if there's one central data heap. And you'd probably be correct. But the argument put forward is that even if that heap was removed, the PDSs would still remain, and the PDSs would still be the ultimate arbiters of the data. So at this point, we have a sort of hybrid centralized and decentralized architecture for storing this data and running the identities. But in a social media world, that's not the only central or decentralized question you might want to ask. For instance, if anybody still uses Twitter, they probably would have noticed that the feed that they see has changed quite a lot since Musk took over. So Blue Sky wanted to avoid the control point that Musk has over the Twitter feed. So what they did is they proposed the concept of a feed generator microservice. So the feed generator is something that consumes data from the relay and it converts it into a feed of posts. And for instance, that decides which posts get included and also the priority ordering of which ones appear first. Now, I want to emphasize that these feed generators are actual microservices. So you can get your server, you can run the microservice locally in your flat or in your office. And that local microservice, completely under your control, can be consuming posts and publishing a feed. Now, you can have thousands of different stakeholders all creating their own feed generator. So then what will happen is the Blue Sky app, so the thing perhaps on your phone or in your web browser, will then connect to any of the feed generators that the user wants, retrieves their feed, and then presents it to the user. Now, at this point, you might say, well, that doesn't sound very centralized, because if everything has to be mediated through the Blue Sky app, Blue Sky kind of control everything. So to overcome this, it's also possible for you to build your own app. So for instance, we could create the DINRG app view, and then that's owned and operated by us, completely distinct from the rest of the infrastructure. So that gives us a level of control that would never be possible in a platform like Twitter, where the ultimate interface will always be managed by that central corporation. Now, the last decentralized component I want to talk about is something which is a sort of political war that's been raging around the world for a few years now, which is the question of moderation. So whenever you run a social media company, ultimately you have to take legal responsibility for what material you're distributing. So that might mean you start removing things like copyright infringing content or stuff that you might classify as hate speech. Now, this becomes really difficult because different people have different definitions of what hate speech is. So to overcome this, Blue Sky introduced the concept of a labeler. So again, the labeler is a microservice that anybody can run themselves. So you can set up your own server, install the labeling service on it, and you can then consume posts from the relay and add labels to them. That can be a manual label that you type in yourself, or it could be some type of machine learning algorithm. But what can then happen is the app views retrieve those labels, and the users themselves can decide which labels they look at and what action point gets taken. So for example, they could subscribe to a labeler which is related to hate speech, and they can tick a box in the interface that says, I want to delete and filter all hate speech from my personal feeds. And actually, this has been taken up even by nation states. So for instance, Germany have built their own labeler, which labels posts which are deemed inappropriate and illegal in Germany. And if you create a Blue Sky account from a German IP address, you'll automatically be subscribed to that labeler. Okay, so now we have a bit of an understanding of the architecture and how it works. We can start to think about some of the measurements that we can do to better understand the central pressures that exist in these systems. And given that this has been selling like hotcakes, there's currently about 32 million users, we think it's worthwhile studying now. So let's take a very, very quick look at some of these microservices. And the first one that might be interesting to you is the decentralized IDs, because in many ways, this is the bedrock of how Blue Sky works. So in front of you, if it loads up, can you see the slides changing?
Yeah, it's a bit of a lag. So I think you want to go back to one slide, I think. So we're seeing the, let's start with the DIDs.
Not for me.
Now we're seeing this graph, a hot domain.
Sorry, it seems to be crashing for me.
Oops.
Oh.
A primer on DIDs.
Right, okay. Sorry about that. Okay, so what you see in front of you here is an excellent Blue Sky account. This is my friend's Blue Sky account. I say my friends, it's actually the cat of my friends. So if you're interested in seeing interesting food by cats, this isn't a good account to follow. Most people will probably assume that in this page, the username is powereats.bsky.social. This is the fully qualified domain name that we were referring to earlier. But this is not actually the case. So in Blue Sky, the real ID is actually a hash-based identifier. And this is basically a SHA-26 of a DID document, which contains all your information. The handles are simply the human represented version, so it makes it easier for us to read. But the nice thing about having these fully qualified domains that we can easily read is it also gives us some hierarchy of control, so we can get an understanding of where people are coming from. So for instance, we saw earlier that Matthias was coming from TU Dresden because he had that fully qualified domain name. So the first thing we wanted to look at is whether or not you get any of these hot domains that emerge that are implicit points of centralization. And the first thing that you see, of course, is that Blue Sky, as an operator, controls about 99% of all of those names. So even though theoretically users have the option to decentralize and control and set up their own accounts, in reality, people would much prefer to hand that control over to a central player like Blue Sky who can do it on their behalf. And this, I think, comes back to some of the early discussion points about the challenges and barriers to decentralization. Ultimately, some things are just much easier to do in a central fashion, particularly from a user's perspective. And if you give users the freedom, often they will take you up on that offer. So that's our DIDs. Let's move quickly on to moderation, because this is one of the really interesting innovations that Blue Sky introduces. Let's just remind ourselves how decentralized moderation works. So anybody can create their own labeler. So here you can see we've got a cat color labeler. So what this does is it will take an image in a post and it will use a machine learning classifier to label the color of the cat. Now, if you're a user with your mobile phone, you can actually search for these types of labelers and you can subscribe to them. So for instance, you can search for cat color labeler and you can click this subscribe to labeler button. What will then happen is in your interface, you'll get an option of what you do when that label is seen in a post. So you can either hide the post, you can add like a fuzzy warning, or you can just ignore it. And what will happen is when you subscribe to these labels, automatically the app view contacts the labeling microservice and retrieves the post on demand. So as you can imagine, this is quite a high overhead because, of course, you've got a lot of communications going on here. So with this, what we wanted to do is check whether or not there'd been uptake both in terms of usage and provision of these labels. So it's a bit difficult to see because the animations are not there, but this is a time series going up to April last year, looking at the number of labelers and also the number of posts that get labeled. So back when we did this IMC paper, there were about 60 labelers that have been created. So a relatively modest number, but not negligible. Since then, the number have exploded. So now you've got over 500 independent labelers that people have created, which you as a Blue Sky user can start using right now. Interestingly though, the vast majority of posts never get labeled. And of course, the reason is that not many people subscribe to all the labelers, and the people who do don't necessarily see all the posts. So still the vast majority of posts are remaining unlabeled. And this arguably is a very good thing, because if you asked every labeler to label every post, this decentralized architecture would fall down, because the overhead of setting up and operating a labeler for every single post in the world would become huge. So this is actually kind of a nice design innovation that Blue Sky introduces. For those who might be curious, this gives you a visualization of the 62 labelers that we had back in April. So along the x-axis is plotting the number of objects that these labelers have labeled. And up the y-axis is plotting the amount of time it takes to generate those labels. So that's the difference between the post being created and the post having the label added. And what you see is quite clear. So the blue dots represent the official Blue Sky labels, and the red dots represent the community-built labelers that people like you or I may have built. So for those that have got a large number of posts labeled, you can see the reaction time is very small, typically below 10 seconds. This is because if you want to scale up to millions of posts, you can only really use machine learning based classifiers. For those that have got a few number of objects labeled, you can see that the reaction time is much, much slower. And these tend to be the community labelers. So these are the manual ones that people can use by looking at posts and adding labels themselves. Now, there are a bunch of different examples of labelers in there. You can probably guess the meaning of things like nudity or porn. A few on the left-hand side I flagged just as interesting examples. So the first one is Agis Blue, which was a community labeler for LGBTQI plus content, or more accurately, content that discriminates against that community. The reason I say this is interesting because there was a little bit of a diplomatic ruckus within the community, and people felt that the labels were inappropriately assigned, so they disagreed with the labels. And this is a big problem with decentralization in these architectures, because there's no one single definition of what a label means. And if you allow anybody to create them, you're going to get clear disagreements between them. And there are no governance mechanisms at the moment to mediate that process. So you can actually create a lot of noise and a lot of confusion in the ecosystem by decentralizing it in this way. Another label, so the first one was for labeling posts. The second one, the pronouns one, is actually for labeling accounts. So you can have accounts labeled, which in itself seems relatively sensible. And you've got use cases such as labeling pronouns, which can be a really helpful service for people. However, it also, again, opens up potential risks, because if you start labeling entire accounts, you actually open up avenues to abuse and harassment, where people might label accounts and, let's say, mistreat them in ways that you can probably guess. Last but not least, of course, the most important, you even have the sorting hat labeler, which can assign you into your house, see if you're in Gryffindor or Slytherin.
Excuse me. Could you please repeat the word slowly that you used about 4 times in the last 30 seconds? That it's just one syllable word with a sounds like tanks. Maybe you could clarify for us.
Sounds like text.
It sounded to me like tanks, TANKS. I don't think that's what you said.
Tags.
Tags, TAGS.
Yeah.
Tags. Okay, thank you.
Sorry, it's my northern British accent. It's a bit tricky. Okay, so now we have these labels. What can we use them for? So the principal use is moderation. So it allows people to decide what they see and what they don't see. And by allowing each individual user to decide themselves which labels they subscribe to, that gives them a lot of control. Another thing these labelers could be used for is helping to generate feeds, because one of the big problems in social media is things like feed bias, where you maybe don't like the feed that Twitter generates for you, or the feed that Facebook generates for you. So as I said before, in Blue Sky, we can actually have these feed generator microservices that anybody can build, and each microservice can run in some bespoke way that you decide yourself. And then individual users can decide which feed generators they like and subscribe to them. So we could maybe use these labels to try to improve the feed generation process. So this is the interface that a user would see on Blue Sky. So you can see on the left-hand side highlighted, there is this feeds button. And when you click on that, this interface pops up and you can search for feeds. So for example, I've typed cats in here, and you can see a whole bunch of feeds that are dedicated to cats. And by clicking on the plus sign, I actually add that feed generator to my interface, and I can click on it and I can see the feed generated by this. So it sort of creates a plurality of different feeds which people can choose between. So the first question is, well, are these feeds decentralized and have they taken off? So these graphs show a time series of the number of feed generators, the number of likes on those feed generators, and the number of follows for the feed generator creator accounts. And you can see across time, all of these are growing. And actually, they're much, much more popular than labelers. So you probably remember back in April, there were 62 feed for labelers. Back in April, there are 40,000 feed generators, so significantly higher. Now we've checked again recently, there's over 100,000. So there's a huge uptake in these feed generators. A lot of people I've been enjoying to create them and sharing them with the community. You can't really see any of this because of the animations, but this gives you a visualization of some of the more popular feed generators to give you an idea of what they offer. So I'll just quickly highlight two from this list. So the first is on the left, so that's what's hot. So this is a feed generator that identifies trending topics from your local social network, so the people you follow. So this is a more heavyweight model because if you build a feed generator service like this, you have to retrieve everybody's post data, check what's hot, and then create a personalized feed for each individual. This highlights one of the other challenges that we get faced with decentralizing social media applications. To make this model work, everything has to be public. You can't have any private data, because if anybody can build one of these personalized feed generators, it means everybody needs to be able to access all the data you have. You know, all the posts you've done, all the likes you've committed, even all the blocks that you may have imposed against people. So at the other end, you have a number of feed generators that are not personalized. Actually, what happens instead is you just have somebody creating a feed. So at the bottom here, you have things like Furry New. So this is a feed generator just for the furry community. And it's not personalized. It's just a curated list of posts that you can subscribe to. So in that sense, it's a little bit like following an account who only reposts interesting content. But again, are there pressures that create decentralization? You know, as I said, we now have over 100,000 different feed generators. But as you can imagine, the popularity of those is not uniformly distributed. There are a small number of very popular feed generators that everybody uses, and then a long tail of feed generators that almost nobody uses. So again, there's always that chance of consolidating power back into the hands of the small number of people who've made really good jobs of building those professional feed generators. One of the other interesting things that we spotted is that the majority of feed generators are not microservices running on the laptop in your office. Instead, what we have is feed generators as a service. So these first three that you see on the bottom graph, Skyfeed, Bluefeed, and GoodFeeds, these cover about 96% of all the generators. And these are professional generator services. So rather than having to build it yourself and host it yourself, these are just cloud services where you can click a few buttons and create a feed. And this is what's triggered the large uptake. This is what's made it possible for over 100,000 feed generators to be created. Again, it's that constant tension between the usability benefits of centralization versus the more philosophical benefits of decentralization. So to conclude, a couple of quick questions. Is Blue Sky decentralized? I would answer yes. It has a number of interesting decentralization innovations in it, which differentiate it strongly from existing platforms like Twitter or Facebook. But the second question, is Blue Sky centralized, also has to be answered affirmatively, because it has introduced components like the relay, which are inherently central. And that is part of the design space that they've had to tackle with, because clearly to make things work, they've had to make some compromises on the full potential decentralization that might be desirable. So with that, I'll conclude. Say thanks again for listening. And if you have any questions, I'm super happy to take them.
Yeah, thanks very much, Gareth. And sorry about the screen sharing.
Okay,
we have some time for questions.
Aram Welling, is this working? Yeah, Aram Welling from Oxford Information Labs.
Hi.
So thank you for sharing this. I think we went back to that picture, which had the three gentlemen on the left-hand side with their URL designated. If we could go back to that.
I think it's this one.
Yeah, that's it. That's it. That's it. So to me, this is not blue skies. This is storm clouds. Okay. This is storm clouds. If you put horns on each of those gentlemen, okay, and you put a horn on the relay in the middle, that's what you end up with in the real world. Okay. It's not nice people with smiles. What you have to prepare for when you design an implementation is the worst case scenario, not the best case scenario. So this completely bypasses any concepts of privacy protection, exposure, inappropriate content. So I just wanted to add that in because to me, this is not blue skies. And it's always interesting to me when things are labeled as such. There's usually a storm behind it. Thank you.
Cool, cool. Yeah, thank you for the comment. And maybe I could just add a couple of quick additional notes here. So blue sky is a mix of several things, because on the one hand, it's an architecture, on the other hand, it's a company, on the other hand, it's a protocol, AT. So things like the relay can be replaced by completely different operators. So if, for instance, blue sky, for whatever reason, does start behaving in a way that people don't agree with, actually all of this is open, so you can create an alternative platform to this which operates completely distinctly from that. In terms of the comment about the misbehavior and like the hate behavior, I would also add that users here are given quite a considerable amount of control over what hits their eyeballs. So these labelers and feed generators can be set up by anybody, and people can subscribe to them locally. For that reason, if, let's say, certain hateful communities form, you can be kept completely distinct from those groups of people if you so wish. The final thing I'd just quickly say is that, you know, blue sky as an operation is constrained by the same laws and regulations that work in any other jurisdiction. So, for example, on the relay, which is a central component, they do have to respect legal requirements. So, for example, if they get legal takedown notices, that content does have to be removed. So it's not decentralized in the sense that it sits outside of the law. But yeah, I agree with the point you're making. I just wanted to add those few thoughts.
Hi, Gareth, Dan Sexton, IWF. Can Blue Sky ban people? Can they ban accounts? And if so, how does that work?
Okay, so yeah, again, it depends on how you define blue skies. So in this operation that you see before you, the answer is yes, because basically everything is mediated through the relay. So if the relay wanted, they could simply filter you out. The other thing worth noting is that these PDSs offer you, at the moment, theoretical decentralization. You know, anybody can create their own PDS. But at the moment, for convenience, the vast majority of users use the blue sky PDS. So again, theoretically, they could remove you. Now, this isn't something that blue sky kind of hide away from. They kind of recognize that this is a reality, and they kind of own the fact that they had to make certain design decisions when they were building this system. I think the argument they'd probably fall back at this point is that they want to work with a model of credible exit. So if, for instance, blue sky tomorrow started blocking lots of accounts and misbehaving, what you could actually do is you could start your own relay. So you could break away, you could start your own relay, you could connect to all the PDSs, it's all public, it's all open, and start running a rival service. And if other people agree, they can move across with you.
Just a quick follow-up. Would they, if you subscribe to the B-Sky TLD, would they remove that part when you'd have to set up your own?
Yeah, so indeed, yeah. So they would manage that TLD. You would have to kind of start up like a dan.social.
Got it.
So that's relatively straightforward to do. So in the architecture, that's kind of a normal process.
Hi, Rowan May. By the way, I quite enjoy listening to your Northern English accent. So I wanted to ask about sock puppets. Like, I get the idea that, you know, that there's a tremendous amount of user control over kind of what you subscribe to, and like who you stop listening to and who you trust and so forth. But I'm curious about your opinion about, you know, basically like open proxies are what killed, you know, XMPP, you know, Jabber. That was, and it was because it was too easy for people to stand up bogus domains, you know, sock puppet servers and so forth. And it seems like it's sort of implied here is that you do want some degree of trust on first use style, you know, like I want to be able to use a relay. So just be curious, a few words about how you feel about that. And and whether there's a reasonable technical solution or social solution to sock puppets?
Great question. So first quick point I'd make is that if, for example, in this example we have here, Mateus creates his own FQDN as a name, that does get verified. So what he needs to do is like put a web object or a DNS object so that they can then check that mateus.tu.dresden.de really does exist. So there is a little bit of an overhead of creating those sock puppets, because of course you'd have to create lots of domains, which to be fair is not so difficult, but it does put a slight barrier. If you're prepared to overcome that barrier, exactly what you said becomes a reality. So theoretically, people could make many, 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 many accounts in the same way that they could create many accounts on a platform like Twitter. The way that Twitter has tried to overcome that is to, of course, build large machine learning models that can automatically flag those sock puppet accounts. There are equivalents in bSky already. So there are labelers that operate, which, for example, try to automatically tag bots. And when they do so, you as a user can choose not to see that content anymore. But architecturally, there's not like a silver bullet that fixes that problem. It's very similar to the problems faced in traditional social media.
Okay, sorry, we're out of time. We had to close the queue. Please ask any other questions on the mail list. And thanks again to Gareth and everybody else for coming. And sorry for Tian, we have to move your talk to the next meeting. Thanks for coming.
Thank you.
Not this week.
Maybe we should have it for Tuesday. But I think with these two talks, IPFS and Blue Sky, we can have lots of things to discuss.
Let's talk later.
If it is a follow-up on the chat, there are a lot of questions.
Yeah. I cannot handle all these things in parallel, chat and the management of the stuff here.